everyone, so in this video we are going to talk about the third big chunk of stuff that's on the PSAT. It's called Advanced Math. It's not really that advanced, it's just Algebra 1 and Algebra 2 mostly, but there will be 14 questions on the PSAT that have to do with this type of stuff. Some might have a calculator, some you might not be allowed a calculator. We're going to kick it off with just a few exponent properties. If you ever are multiplying and you have the same base, you just add up the exponents, because this is x times x, and this right here is 3x's, and if you multiply them all together, you have 5. If you have a power to a power, you multiply the exponents. So 2 times 3 would be 6. Again, if you're not sure, you could write it out. X squared 3 times would be x squared times x squared times x squared, which you can see is 6 of them. When you have division, you subtract the exponents. And it's usually easier to start with the bigger one, so if we have more x's on the bottom, I'll do 3 minus 2, which leaves 1x on the bottom and nothing on the top, so I'll just put a 1 there. You don't really need to put x to the first power, you could just put 1 over x. If you had more x's on top, like x to the 7th over x cubed, you would just do 7 minus 3, which is x to the 4th. Another way of thinking about this is if you did 2 minus 3, it's x to the negative 1. And negative exponents we'll talk about in a second, but you'll see why these kind of match up. And anything to the 0 power is 1. In this case, all of this is to the 0 power, so it's just a 1, but the 5 was by itself. So we have 5 times 1, which is 5. A few more here. If you ever just have multiplication or division, you can just kind of distribute that exponent. So this would be the same as x squared y squared. Or in this case, we have 4 times 2, so x to the 8, and 1 times 2, so y squared. Division, it works the same way, so if I have x over y squared, that's the same as x squared over y squared. However, this does not apply if you ever have multiple terms. So if you ever have a plus or a minus in here, you cannot just square them both. You have to actually multiply it out because you're going to end up with more terms. So x minus y squared is the same as x minus y times itself, because that's what squared means. And you'll see when I multiply this out, I get quite a bit. X times x is x squared. X times negative y is negative xy. This is also negative xy. And then negative y times negative y is positive y squared. And then if I combine these two, they don't cancel. I have negative xy and then another negative xy, which makes negative 2xy's. Combine those like terms. And then x squared plus y squared. So that is my final answer there. Okay, let's talk negative exponents here. Negative exponents become positive if you just change whatever side of the fraction it's on. So for example, 5 to the negative 2 power, if we move it up to the top, becomes 5 to the positive 2. And times 1, which is just itself. And then 5 squared is 25. So that's the answer there. This one is currently on the top of the fraction, and so we'll move it to the bottom to make it positive. So this will be 1 over 5 squared. And again, 5 squared is 25, so it's 1/25. Let's get a little more crazy with these negative exponents. So the negative 2 can stay where it is, but if I want to make x to the negative 5th not be a negative, I'll move it to the bottom, so it's positive x to the 5th if I move it down. And this one can stay, y cubed is fine. And then to make this one positive, I'll move it up. So z to the positive 2 at the top here. And that would be my final answer. It's all simplified just because they're positive exponents now. Let's talk scientific notation real quick. When you have scientific notation, it's like times 10 to the power of. Basically, this is how many zeros you're supposed to have. So you just move the decimal place that many times. So if it's a positive number, it's going to be really big, so you move the decimal to the right. If it's a negative exponent, it's going to be a really small number, and you move the decimal to the left. For example, this one, we move the decimal to the right 5 times. So 1, 2, 3, 4, 5, and you would just fill those in with zeros, and so you can see that we get this. On this one, we move the decimal to the left 6 places. So 1, 2, 3, 4, 5, 6, and then fill in zeros, and that's how you get this. Let's talk fraction exponents now. Fraction exponents are actually radicals. So if I have 8 to the 2/3 and I want to express that in a different way, remember 8 to the 2nd power stays where it is, and then the 3 is actually a radical of 3. So whatever is on the bottom of the fraction, so if you have this exponent, whatever's on the bottom of the fraction is actually the index of your radical. So these two things mean the same. 8 squared cube rooted is the same as 8 to the 2/3 power. And so you can rewrite it either way if it helps you to simplify. Also, the radical can go over just the number, or it can go over the exponent too. It actually doesn't matter. I'm going to put it over just the 8 because I know the cube root of 8. It's 2, because 2 times 2 times 2 is 8. So the cube root of 8 is 2, and then 2 squared is 4. So 8 to the 2/3 power is actually 4. If you had your calculator, you could do this on the calculator. Do 8 to the 2/3 power, and it would give you 4. So here's kind of that rule. The power and the root itself can become a fraction, and you can go back and forth based on whatever you need. Just remember that whatever's on the bottom of this fraction here is actually like the index of your radical. For example, if I wanted to rewrite this as an exponent, I would leave 2 to the 10th as it is, but divide it by 5. So divide this by 5. Which 10 over 5 is just 2, so this is 2 squared. So 4. This one, if I want to evaluate it, which just means see what it equals, I'll leave 9 to the 1st as it is, but this 2 here becomes my index. So 9 to the 1st power is just 9. So I'm just finding the square root of 9, which is 3. Let's do a little bit more with some radicals here. With radicals, you can multiply them. So like in this case, I would multiply whatever's outside the radical. So 6 times 7 is 42. And whatever's inside the radical. 8 times 2 is 16. And then if you can ever simplify them or break them down, you want to do that as well. So the square root of 16 is actually just 4. And then do 4 times 42. 42 times 4 is 168. So that'd be our final answer there. On this one, we're adding. If you are adding or subtracting radicals, they have to be like terms. And by like terms, I mean they have to have the same radical. Like if this one's square root of 2, this one also has to be square root of 2. So as they are, I can't add them. However, 8 will actually break down a little bit. 8 splits into something that I could square root evenly, 4. So if I split 8 into 4 times 2, it breaks down a bit, and so the square root of 4 is 2, and 2 times 6 is 12. So now this whole thing just becomes 12 root of 2. All right. So now I actually do have like terms. I have 12 root of 2 plus 7 root of 2, which, since they have the same radical, they're like terms. So I have 12 of this plus 7 of it, and so 12 plus 7 is 19. And the root of 2 part just stays as it is. Just like you were adding 12x plus 7x would be 19x, it's kind of the same idea. All right, on this one, there's a couple ways we can handle this. When you're multiplying or dividing radicals, you just kind of squash them all into one. So the 6 over 7, I'm just going to leave 6 over 7 because that doesn't really simplify. There are a couple ways you could handle this. You could break down the 8 like we just did and make it 2 root of 2 and then cancel out the square root of 2's. Or you could divide 8 divided by 2, which is the square root of 4. And the square root of 4 is 2. So now I have 6 times 2, which is 12 over the 7. All right, so that's all the radical and exponent stuff. Now we're going to get into some function stuff. So just to start off a little basic, let's say I have this function and I want to take function g and put -5 in as the input. All you do is take out the x's, which are just placeholders, and put in -5. So don't forget to use parentheses, especially with something like this squared here. I just put all that in your calculator, but this is positive 25 minus 35, so -10 plus 8 will be -2. That's your output that goes with this input. On this one, they want us to use the function f of x, which is this table. It's a list of inputs and outputs. I want to know what function f is when my input is -2, which happens here. When the input is -2, the output is 4. So that's the answer. All right, let's get a little more interesting with functions here. If you remember, we've talked about composing functions, which basically means put a function into another function. So we're going to use the same g of x and f of x as the previous problem, but this time we're going to do f of g of -5. It might look like this, it also might look like this. These mean the same thing. The little o means you do f of g of -5. When you do problems like this, you always want to start on the inside first. So basically, we're going to find g of -5, and then whatever we get, we're going to put that into the function f. So let's just start with g of -5, which we did on the last slide by plugging in -5, and we got out -2. So when we do g of -5, we get out -2. Meaning, I'm going to replace this entire thing with -2. And so now, I'm just finding f of -2, which we also did on the other slide. It's almost like I planned this. F of -2 is right here. Input is -2, the output is 4. And so the entire answer here of f of g of -5 would be 4. Let's try another one like that. As you work through these, pause and try the problem on your own, and then watch me go over it. Again, we're going to start on the inside. So let's start with just g of 2. So go find function g, which is here, and put in a 2. So 2 times 2 squared. Put a 2 in for x. Exponents comes first, so 2 squared is 4, and then 2 times 4 is 8. So that's g of 2. So I'm going to replace this with 8. So now I'm finding f of 8 over f of 2. Don't try to like divide or cancel any of that. You need to just plug in 8 to the function f and then separately plug in 2 to the function f. If I plug in 8, I get 8 squared plus d, and I don't know what d is yet. That's what I'm trying to find. And f of 2 would be plug in 2 here. So we'll do 2 squared plus d. And so simplifying a little bit, 8 squared is 16 plus d, and 2 squared is 4. Whoops. And it tells me that this entire thing was supposed to equal 4. So how do I make this equal 4? So maybe you can kind of just figure it out. It's not that hard to kind of guess around and figure out what d should be. And then you could also solve it. And the way to solve this equation, these don't cancel because this stuff is stuck together and this stuff is stuck together. Any numerators and denominators kind of have parentheses around them that are understood. The way you would have to solve for this is multiply both sides by 4 plus d. And multiply this side by 4 plus d, which would cancel that out. And so then you'd be left with 16 plus d equals 16 plus 4d. And then subtract d from both sides. So you get 16 equals 16 plus 3d. And then subtract 16. And you get 0 equals 3d. And then finally, divide by 3. And you get 0 for d. Which we could kind of see that right here. 16 over 4 is already 4, so the d values would have to be 0. You good? Feel free to move around. Sorry, I'm going to be making this video. All right, while we're talking about functions, let's talk about transformation rules. So if you take a function, you can shift it up, down, left, and right by adding in values. If you add in a number right there with the x, it shifts it in the x direction, so left and right. If you add in a number on the end, it shifts it up and down. The one in there with the x, anything that happens in parentheses is kind of opposite of what you would expect with transformations. So for example, if I had f of x minus 3, it seems like this should move your graph left 3, but it actually moves it right 3. Just like this shows here. And if it's a plus, it actually moves it left. The number on the end does exactly what you would expect. So let's say I have a function and then I add 3 on the end, it would shift it up, whereas if I subtracted 3 on the end, it would shift it down. We don't know what f of x is, but it applies to literally any function. So for example, let's say we're using the quadratic parent graph, x squared. If I do x squared plus 1, that's our usual parabola just shifted up 1. Or if I do x minus 3 squared, this is going to shift the graph right 3, because it's right in there with the x. This applies to any parent graph, so let's say we're looking at 2 to the x, which is that exponential graph. And then I do like minus 4 on the end, it shifts it down 4. So these same transformation rules apply no matter what function you're talking about. That's why we're just generically using an f of x here. If you put a negative in front, it flips the graph upside down. It reflects it across the x-axis. So for example, again, let's talk about x squared, which is our parent graph for quadratics. If I put a negative in front, it flips it upside down. Sorry, that got a little shifted too, I didn't mean to. This is one we haven't really talked about much, but I thought I'd mention it. If you put a negative inside the parentheses right there with the x, so like let's say I did negative x squared, that actually flips the graph across the y-axis, like vertically. And the last thing is, if you multiply by a number in front of the graph, it vertically stretches it or shrinks it. Sometimes a shrink is called a compress. If it's a number bigger than 1, it stretches it. Like if I took your height and I did like 3 times your height, I would be vertically stretching you. So like if I have x squared as my parent graph and then I do times 3, it's going to be a very stretched parabola. Whereas if I had 1/3 x squared, that's going to squash it down and it will be a wider parabola. So here's a few examples. What would the graph of this look like? Well, it starts with the parent graph x squared, which is a parabola that hits at 0, 0. However, it got vertically shrunk or compressed by 1/3, so it got kind of squashed wider, and bumped down 3. So it's moved down 3 and it's a little wider. So it would look something like that. This is also a parabola, x squared, but it, first of all, the negative flips it upside down, and the 5 vertically stretches it. So it's flipped upside down and it's vertically stretched, and then it's also shifted left 1 and up 2. So left 1, up 2. So right here. And so that's generally what the graph would look like, is this right here. This one starts with the parent graph 2 to the x, which is the exponential graph that goes through 0, 1, and it has an asymptote at 0, and it looks like this. Except for it got flipped upside down because of the negative and bumped up 3. So we'll bump it up 1, 2, 3. It now goes through this point. And instead of being at 0, the asymptote gets bumped up 1, 2, 3 as well. And so, and it's upside down. Oh, sorry, got flipped upside down. So it would now be down here. So it doesn't go through that point. So it looked like that. All right. In this case, we're just going to use a generic f of x as our function. Which of the following represents f of x after it's been reflected across the x-axis, so put a negative in front, and then shifted left by 4 units, so that'll be right in there with the x, and then shifted down 5. The answer would be this one. The negative reflects it. The plus 4 here moves it left 4, because in the parentheses is opposite of what you would expect. And then the minus 5 moves it down 5. All right, so let's get into quadratics a little bit now. So here's an example. A toy rocket is launched vertically upward from a platform. This is its height. And I want to identify some various things. If you have your calculator on you, you could graph this in your calculator, but you don't really have to. I can see that this is, its vertex is at 210 because it got moved right 2 and up 10. So right 2, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's its vertex, the height of it, and it's upside down because of the negative, so it got flipped upside down. And I know that typically it goes down by 1, and then 1, 2, 3. So there we go. All right. Let's keep going, I guess, all the way to the ground. The first question is, how long will it take for the rocket to return to the ground? That's going to be right here, where it hits the x-axis. Again, if you have a calculator, that's probably the easiest way to do it. But really I want to see where does y equal 0? And so one way to do this would be substitute a 0 in for y, or h of t, and solve it. So I could subtract 10 from both sides. So negative 10 equals negative x minus 2 squared.
Diamond Francisco, report to the media center, please.
Then
Diamond Francisco, report to the media center.
I got to get rid of this negative, so divide by a negative 1. So 10 equals x minus 2 squared. Then I could square root both sides to get rid of the squared. When you do that, don't forget plus and minus when you square root. So plus or minus square root of 10 equals x minus 2. And finally, I'll add 2 to both sides. And so the x values where this hits the y-axis, sorry, the x-axis, are at 2 plus or minus the square root of 10. If you want to get an actual decimal out, you'll need to split that up. So 2 plus the square root of 10 gives you 5.16 approximately, and 2 minus the square root of 10 gives you negative 1.16 approximately. That's obviously not the one we want because we don't want to talk about negative time. We want the one that's positive. So about 5.16 seconds is how long it takes the rocket to return to the ground. How long will it take the rocket to reach its maximum height? That would happen right here. And the time it takes is t along the x-axis. So that would be 2 seconds, it hits a height of 10. So after 2 seconds, it reaches its maximum height of 10, and what was this in? This was in feet? Does it say? No, it doesn't say. We can maybe assume it's feet, but 10 somethings. All right. Lastly, I want to know what is the y-intercept and what does it represent in this scenario. I thought it was approximately, because I go over 1 down 1 and then like 1, 4, so it's probably somewhere around 1, 2, 3, 4, 5, 6. But if you're not sure, you can always plug in a 0 for x and see what you get out for y, because this is where x is 0. So if I do negative 0 minus 2 squared plus 10, I get negative 2 squared. Negative 2 squared is 4, and then make it negative. Yeah, so it is 6 like I thought. So what this tells me is when time is 0, the height is 6. And so that actually represents in this scenario the starting point. It said that you were on a platform, so it must be that the platform is like 6 feet or whatever we're talking about. It's 6 somethings in the air, and then it goes up a bit and comes all the way down to the ground. All right, so let's try another one like this. You've got a velocity of a ball thrown upwards, represented by this equation. V is velocity, t is time, in seconds. After how many seconds does the velocity become 0? So once again, I want velocity to be 0, so I want this to be 0. I'm going to need to solve this equation. There are many ways to do this, and we're going to talk about this in a second, but maybe the easiest way is just to try the answer choices in this particular problem. Like if you put in 2, does negative 5 times 2 squared minus 20 times 2 plus 60, does that equal 0? And so negative 5 times 2 squared minus 20 times 2, and it does. So there we go. It equals 0. If you try some of the others, like I'm trying 12 right now just to see what happens. Yeah, if you put in 12 for t, you end up getting negative 900. So it's definitely not that one, that's too low. So it's after 2 seconds, because when I plugged in 2, I got out 0. And you can solve this. We'll talk in a second about how to do that. So there are many ways to solve a quadratic. If you can ever just get, oh goodness, if you can ever just get x by itself, like we did on a couple problems ago, then do that method. However, sometimes you have multiple variables and you're not able to. To solve a quadratic, you could also look at the graph, because if you look at the graph of a quadratic, wherever it hits the x-axis, those are its solutions. So, like here and here, let's say this is -3 and this is 2, those would be the solutions to this quadratic. If it doesn't hit the x-axis, then it doesn't have any real solutions. So if it looks like this, it has 2 solutions, they're just imaginary. You could also solve by factoring. If square root method doesn't work, factoring is usually a good next bet. Try to factor it and see if you can find the solutions. Remember, you got to set the factors equal to 0. And if all of that fails, you can use quadratic formula, which you will need to memorize. They won't give it to you. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So you just plug in a, b, and c. So for example, if I wanted to solve this quadratic, this one is one where you can use the square root method. Just get m by itself. Just get everything away from the m till you've got it. So add 3. So 9m squared equals 4. And then I got to get rid of the 9, so divide by 9. Leave the 4 ninths, because when I square root this to get rid of the squared, I can square root both of those. Don't forget, when you square root a number, it could be plus, but it could be minus. So we need a plus minus there. And so I have m by itself. It equals plus and minus. The square root of 4 is 2, and the square root of 9 is 3. So there we go. So I have 2 answers, and with quadratics, you're going to get 2 solutions. Occasionally they repeat, so you just get 1, and sometimes they're imaginary, but you always get 2 solutions. All right. Again, if you have a graph, all you have to do is find the x-intercepts. By the way, just a reminder, the solutions to a quadratic have many names. They're called x-intercepts, they're also called roots, and they're also called zeros, because it's where the graph equals 0. So the roots are just the solutions, and again, it's the x-intercepts, -1 and 2 in this particular case. That's it. You could plug them in and make sure they work. Like if you did 2 squared minus 2 minus 2, you would get 0. All right. How many real roots does this quadratic have? It has 0 real roots because it doesn't hit the x-axis. It has 2 roots, they're just imaginary. All right. This one we're not going to be able to just get x by itself because I've got x squared and x, and those are not like terms, so I can't combine them, but like I can't get x by itself if there's 2 of them. So in this case, you could either graph it and see where it hits the x-axis, or factor it. Factoring is usually a good next step. To factor this, it's 3 terms, so I do rainbow method. I'll multiply the 1 in front times the 9 in the back, and that's my rainbow number. So I want to find 2 numbers that multiply together to give me 9, and add to give me the middle number, -6. And that would be -3 and -3. So I fill those into my factors, x minus 3 and x minus 3. Okay. To get from the factors to the actual solutions, you have to set the factors equal to 0. So I want this whole thing to equal 0, so either this x minus 3 equals 0, or this one equals 0. This one's kind of weird because they're going to give me the same solution twice. If I solve for x, I get 3. here, and I also get 3 here. So the solution is just 3. You don't really need to put it twice, but it did pop up twice. If I wanted to draw a quick sketch of this graph, I know that since 3 is a solution, then it would have to hit the x-axis at 3, right here. And since there's no negative in front, I know that it opens up. So it looks something like this. Right, so let's try another one. And this one I want to, again, find x. I just want to solve it. If you had answer choices, you could just plug them in and see which ones work, but I don't here. I'm probably going to get 2 solutions, keep that in mind. Again, square root method won't work because I have an x and an x here, so I'm going to try factoring. To factor it, you multiply 2 times 3, which is 6. So I want 2 numbers that multiply to give me 6 and add to give me 5. And that would be 5 and, nope, 2 and 3. All right, so fill those in your factors, x plus 2 and x plus 3. Except for, gotta be careful, if you ever have a leading coefficient, it's not a 1, you need to divide or slide with it. What I mean by that is you either divide it or you slide it. This one, the 2 divides in evenly, so that becomes x plus 1. On this one, the 2 doesn't divide in evenly, so we slide it over and get 2x plus 3. Those are my final factors. Now, to solve it, you set them both equal to 0. So x plus 1 equals 0, and 2x plus 3 equals 0, and then solve. So negative 1 is one of my solutions, and then here, I get 2x equals negative 3, divide by 2, there we go. Negative 3 halves is the other solution. All right, sometimes they might do some of the work for you. It gives you this equation here, and it wants to know what are the values of x, so like solve for x. This one, it might be tempting to like multiply it out, but you don't want to do that. You're trying to solve it. To solve it, you factor and then set the factors equal to 0, and it's already factored for you. All you gotta do is set factors equal to 0 and solve. And you'll probably notice it's pretty much just the flipped version. So if I have negative 1 here, I get plus 1 as a factor, or sorry, as a solution. And if I have 4 here, I get negative 4 as a solution. So the answers would be 1 and negative 4, so 2 and 4 would be B. Again, this is one where you could plug them in and see if it works too. Like if I plug in 1 for x, I get 1 minus 1, 1 plus 4. 1 minus 1 is 0, times 5 is 0, so it works, it gave me 0. All right, I wanted to point out that this doesn't actually just apply to quadratics. It applies to crazier things as well. So this one would be a cubic function, it's x times x times x. But as long as you just have the factors and you set the factors equal to 0, that's all you have to do to solve an equation that's equal to 0 like this. For example, this one would have a solution at negative 1, positive 3, and 1/2, because if I do 2x minus 1 equals 0, add 1 to both sides, 2x equals 1, divide by 2, so 1/2. So I would have 3 solutions. 1/2, 3, and negative 1. You could also always just find the x-intercepts. So even if you have a super crazy function that looks like this, the x-intercepts are always the solutions, or roots we call them, zeros. This one has one at negative 3. It has one at 2. This one probably repeats. When it hits but then goes back down, it usually repeats. So it's probably 2 at 2, and then 1 at 5. So those are the zeros, 5, 2, and negative 3. Also, if these are the zeros, what would the factors be? Think about kind of going backwards. If I have negative 3 as a solution, I would have x plus 3 as a factor. If I have 2 as a solution, I would have x minus 2 as a factor. And again, that one's probably there twice because it hits and then goes back down, so that one's probably squared. And then if I had positive 5, I'd have x minus 5 as a factor. The last option you have is plug in the answer and see if it gives you 0. So like if you want to know, is 2 a root, aka solution 0, of this crazy equation here, all you have to do is plug in 2, see if you get out 0. That's what it means to be a root or a solution is. Do you get out 0? So if I do 4 times 2 cubed minus 9 times 2 squared plus 3 and put all that in my calculator, 4 times 2 cubed minus 9 times 4 plus 3, I got negative 1, which is not 0, so no. You have to get out 0. By the way, this and this are basically the same question. Is 2 a root is asking the same thing as, is x minus 2 a factor? Because to tell if it's a factor, I would turn this factor into a solution, you would do plus 2, and you would get x equals 2. So basically, these are asking the same thing. All right. I wanted to mention, we did systems of equations with lines, but systems of equations don't have to be just lines, but it works the same way. If you want to see the solution to a system of anything, you just look at where the graphs intersect. Because this blue equation represents all the solutions to this quadratic here, and this red line represents all the solutions to that equation. And so the solutions that work for both of them would be here and here, where they intersect. So 0, 3, and 4, negative 5. Both of those are solutions to this system here. You could also use the substitution method. For example, if I wanted to substitute one of these equations into the other, I could take this and substitute it for y in this equation. Basically, since they both equal y, then they could equal each other. So I would have negative 2x plus 3 equals x squared minus 6x plus 3. And then to solve this, I move it all to the same side. So I get 3x squared minus 4x plus 3. Then I'm going to subtract 3 from both sides. See ya. Okay. To solve this, I'm actually going to factor out a GCF of x. And once you factor out x from both terms, you're left with x minus 4. Again, I'm just going to set both of those factors equal to 0. If I set x equal to 0, that actually is a solution, 0. And if I set this equal to 0, I get positive 4. So those are my two solutions for x. You can see that 0 and 4 were my two solutions. To get the y values, you just plug it in. So put 0 in, negative 2 times 0 plus 3 gives you 3, which is why I had the point 0, 3. Or if I put in a 4, negative 2 times 4 plus 3 is negative 5. So that's how I get those 2 points algebraically. All right, if all else fails and you can't factor and you can't graph it, you can use a quadratic formula. Remember with the quadratic formula, whatever's in front of x squared, or in this case m squared, is your a. Whatever's in front of the m, or x, is your b, and then the constant by itself is the c. And then you just fill them into the formula. So in this case, it's negative b, so negative 7, plus or minus, the square root, of b squared minus 4ac, just filling in a and c, all over 2 times a. And then you just simplify one piece at a time. Negative negative 7 is positive 7. 2 times 4 is 8. And then I'm going to leave the square root because it might not square root evenly, but I'm going to put all of this just in my calculator. It wouldn't be that hard to do by hand. 49 minus 16, which is 33. And that's actually the answer. If I could square root this, I would. If it breaks down at all, I would break it down, but 33 doesn't divide by 4 or 9 or 16, so that's just it. That's my answer. All right, let's talk about just a little bit more of some algebra simplification, especially with division. If you're ever adding or subtracting fractions, you've got to have a common denominator. So this applies to algebra as well. Don't let this throw you off. If x is not equal to 0, just means x can't be 0 because we can't divide by 0. That's all that's saying. I want these to have the same denominator. Since this one has a 5, basically these need to have a 5 as well. So I'll just multiply it by 5. And if I do it on the bottom, I'll do it on the top, and that basically keeps it balanced because 5 over 5 is just a 1. Same thing here, do times 5 and times 5. And now they all have 5x in the denominator. So I've got 5u plus 25u minus u all over that common denominator, 5x. Just like if I had 1/5 plus 2/5 minus 3/5 or something like that, I could do 1 plus 2 minus 3 all over 5. It's the same idea. Let's combine these. 5 plus 25 is 30, minus 1 is 29u, all over still 5x. Nothing else simplifies or divides there, so that's my final answer. Sometimes it's helpful to put them all together like we did on this problem, but sometimes it's more helpful to split them up. So like in this particular problem, I'm going to divide both of these by the 2x squared. So I'll have 10x to the 6 divided by 2x squared, and then also 8x to the 4th divided by 2x squared. 10 over 2 is 5, and if I have 6 but take away 2, now I have 4. 8 divided by 2 is 4, and then I had 4 x's but cancel out 2 of them, so now I'm left with 2. These are not like terms because they don't have the same exponent, so that's my final answer. Goodness. Just be careful when you're canceling things out. If you're going to cancel stuff out, it has to just be multiplication. For example, none of this cancels. Like, it's really tempting to be like, oh look, the x squareds can cancel out. But there's kind of understood parentheses in the numerator and in the denominator, and so this is all stuck together. The only way I could cancel out is if I had another x squared plus 3 on top. They would have to be exactly the same. So you can't just cancel pieces of this. You can't just cancel x squareds. You can't cancel the 3's. Nothing cancels yet. So what you could do is if nothing cancels, you could try and factor it. Because if stuff is factored, then it will cancel. Because you see how these are all just multiplied together? And so now I can just cancel those x's, and I can cancel x plus 6, and now all I'm left with is x minus 6. All right, let's try another one like that. So you might have to factor yourself, and this problem's a little crazy with the factoring, but I just wanted to show you like as crazy as this might get. So this is technically just a fraction divided by a fraction. And so this is keep, change, flip. You keep the first one, change this to multiplication, and then flip the second one. So now it's x over x squared plus 5x. Okay, To multiply fractions, you just multiply across the top and across the bottom. However, I might be able to cancel some things if I factor, so I'm actually going to factor stuff first. On the top, I've got x, and then this one is the difference of two squares. The way you factor that, if you remember, is you square root the first thing. Square root of x squared is x. You square root the thing in the back, so square root of 25 is 5. And then you make one plus and you make one minus. So this just turned into this. So that's the numerator. In the denominator, I've got this and this. Let's factor them both. This one has 3 terms, so I'll do rainbow method. 3 times negative 5 is negative 15, so I want two numbers that multiply to give me negative 15, and add to give me negative 14, which would be negative 15 times 1, and negative 15 plus 1. So fill those in your factors, but be careful. We need to divide or slide on this one with the 3. So divide it or slide it. This one divides in evenly, so we get x minus 5. This one doesn't divide, so we slide it over and get 3x plus 1. Those are my factors. I don't need to set them equal to 0. I'm not trying to solve here, just trying to factor. So these turn into this. So I've got x minus 5 and 3x plus 1. Finally, I'll factor this. This one's a little weird. It has a GCF of x. When you take out that x, you're left with 1x plus 5. And so this factors into this. So x times x plus 5. Now that it's all factors, I can cancel stuff. And you'll notice I have quite a few that are the same. The x's cancel. The x minus 5's cancel. The x plus 5's cancel. I'm actually out of stuff on the top. I'll put a 1 there. And so my final answer is 1 over 3x plus 1. That's my final answer. It all simplified to that. Again, be careful. The ones don't cancel because of this plus. The entire thing has to cancel. All right. So that's the end of the advanced math section. There will also be 2 questions on the PSAT that have to do with what they call additional math topics, which is basically just geometry stuff, things we've done this year. We're not going to really go into that because we did it this year, and also because there's only 2 questions. But they might ask you to use volume formulas. You might have to do some trig, so keep in mind SOHCAHTOA with your right triangles. You might have to use Pythagorean theorem. Remember, the sine of one angle equals the cosine of another as long as those angles add up to 90. There might be some complex or imaginary numbers on the test. Remember, you add and subtract and multiply these just like you do with x's, basically. So like 3i plus 5i makes 8i. Those are like terms. And negative 1 plus 9 is 8. So that would be it. Remember, I is technically just the square root of negative 1. So keep that in mind. When you multiply, 3 times 5 would be 15i squared. And then 27i minus 5i minus 9. So I squared, if I square this, I squared, square root and squared cancel, and it's actually just negative 1. So I'm going to replace I squared with negative 1, which gives me negative 15 minus 9, which would be negative 26. Sorry, negative 24. And then 27 minus 5 would be 22i. Final finally, you might have to do some things with congruence and similarity, and there will be a few topics we haven't quite covered yet that are a little more pre-calc, so just be aware that that might be on the test too.